theorem to this class, you would say every polynomial function has at least 1 0 in the complex numbers. Is that a hint enough? Did you guys star it yet? The star next to it yet? Okay. All right. The next theorem was the conjugate pairs theorem. And again, going back. What's nice about this is this tells us that there is an answer. We just have to find it. The conjugate pairs theorem is quite straightforward. If a plus bi is a 0, then so is a minus bi. Those are conjugates of each other, right? And that works the same thing for square roots. And that comes from the quadratic formula. You guys remember the quadratic formula has that plus or minus in front of the square root? Plus, minus in front of the square root. That's where it comes from. So that's just that theorem right there. So what we're going to talk about right here is going backwards before we do more factoring. And you have to give me the polynomial function before I give you the function and I ask you to find a 0. So we're just going backwards now. So if I tell you I want to find the polynomial function, it has to have real coefficients that has 1 and 3 minus I as zeros. So if 1 is a 0, here's what's important. If 1 is a 0, then x minus 1 is a factor. Let's say that again. If 1 is a 0, then x minus 1 is a factor. You guys remember that? All right. Also, if 3 minus I is a 0, then x minus 3 minus I is a factor. You guys okay with that? Maybe? Maybe? It was easier when it was just the number 1, right? Yes. I'm going to say the top one too, just for fun. If 1 is a factor, scratch that. If 1 is a 0, then x minus 1 is a factor. If 3 minus I is a 0, then x minus 3 minus I is a factor. You just did x minus the 0. X minus the 0.
Okay.
Does that make sense? Those are facts. I've now just given you a couple of facts. Here's another fact. So the question is in black. Everything I'm doing in color is my work. If 3 plus I is a 0, what else is a 0?
3 minus I.
Oh. Did I say it wrong? My bad. If 3 minus I is a 0, then 3 plus I is also a 0, right? What theorem does that come from? Conjugate pairs theorem. So that means since 3 plus I is a 0, I also have x minus 3 plus I as a factor. So you list out your zeros, then you list out your factors, and then you have to go back and answer the question. It asked me to find the polynomial with real coefficients. So do you guys remember when you had something like x squared minus 4, and it factored into x minus 2x plus 2? So basically we're just going backwards. We're going to take that x minus 2x plus 2 and multiply it together. So I'm going to take those 3 factors and multiply them together to get the polynomial. Going backwards with factoring. Opposite. Okay. So this is then going to become, I've got x minus 1 times x minus 3 plus I, x minus 3 minus I. So can you see how I did from here to here, I distributed the negative inside the parentheses. So from here to here, I distributed the negative inside the parentheses. Say it again. From here to here. What did I do?
Distributed the negative inside the parentheses.
Good. You guys are real good at memorizing what I say, at least, right? So I just took this negative and distributed, that's why it became plus I. I took this negative and distributed, that's why it became minus I. And so now I got to multiply all this out. And I'll give you guys a hint. Whatever factor has only real numbers, do that one last. Do the imaginary numbers first to get them out of the way. It's going to make multiplying easier later on. So do the imaginary numbers first. So I'm going to deal with those two first. And I'm going to have a little work on the side here, some scratch work. That's an x minus 3 plus I times an x minus 3 minus I, right? I got to multiply that together. So I would do x times x, which would give you what?
X squared.
Excellent. And then I would do x times negative 3. And then I would do x times negative I. Then I would do negative 3 times x, negative 3 times negative 3, and negative 3 times negative I. Then I would do I times x, I times negative 3, I times negative I. Does this sound like fun to do? Could you do it? Everybody say yes so I can skip it.
Yes.
Okay, so now that I know you can do it, I'm going to show you the shortcut. Okay, so notice these two factors that I'm trying to multiply. Are they almost similar? Really darn close, right? What's different?
Plus I minus 1. So you can take out the negative.
They're conjugates. They're conjugates of each other, right? This has an x minus 3 plus I. This has an x minus 3 minus I, right? They are conjugates of each other. So this is just like your a plus b times your a minus b, right? And don't you remember that difference of two squares? A squared minus b squared.
What's your x minus 1 though? Yeah, you see that.
I haven't used it yet. I'm going to come back to it, yeah. No, I will. Thank you. I haven't forgotten it.
So it's x minus 3 squared minus I squared.
Right. The a squared minus the b squared. See how that's a lot faster than actually this times this, this times this, this times this. It gets real tedious quick. A plus b,
Oh.
a minus b. The a was your x minus 3. So I take my x minus 3 squared minus the b was the I. So it's the I squared. A squared minus b squared. And then this you can simplify. So this becomes the x minus 3 times x minus 3 minus, what's I squared?
Negative 1.
And then this we can FOIL. Notice how I got rid of all my i's? It's quicker. Less i's. Easier to multiply. So then this is going to become x squared minus 6x minus plus 9 plus 1. Because those two turn into a positive. And then that would have become an x squared minus 6x plus 10.
Now you add your x minus 1.
Yeah, now we're not done quite yet. But yeah. Let me make sure everybody's caught up with this part. This is sort of my multiplying these two over here on the side. Yeah. That's okay. Are you okay with this is the fact that this is an a plus b times a minus b? So that was the a squared minus the I squared. X minus 3 squared is x minus 3 times x minus 3. I squared is negative 1. And then I FOILed this. I skipped a step, but I FOILed this. And I got this. 2 negatives gave me a plus 1. And then the 9 plus 1 gave me this. Just combined like terms. So now I go back to here. And I'm going to call this f of x just for fun. And now I have an x minus 1. Now I have an x squared minus 6x plus 10. So now I got to bring in that x minus 1 still. You guys okay with that part? Now what do? I got to finish multiplying it, right? So now you multiply that. So now I'm going to do the x times the x squared, which gives me what?
X cubed.
And then x times negative 6x.
X squared.
X times 10.
10x.
And then I do negative 1 times x squared.
Negative x
And
squared.
then throughout the rest of it. I got one nod. I'm going to count 2 nods. And a lot of blank stares. Are there questions? Okay. Could I combine some like terms?
Yeah.
So what is this? X cubed minus 7x squared plus 16x minus 10? So I found a polynomial with real coefficients that has 1 and 3 minus I as zeros. It also has 3 plus I as zeros. Oh, okay. Yes. Questions? Is it okay if I erase this? I have it typed up for you guys. What does the direction say?
F of x is a polynomial of degree 6 and blah, blah, blah are the zeros found in zeros.
So the question is to find the other zeros, right? Did I ask you to find the polynomial?
No.
So don't multiply it out unless I've asked you to. Here I asked you to find the polynomial. So I had to multiply it out. Here I am just asking you to find the other zeros. So you're just finding the other zeros. What are the other zeros? Negative 3.
3 plus I.
3 plus I.
5i.
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 2 plus the square root of 7.
Conjugates. What theorem does this come from?
Conjugate.
Shut up. Don't start doing x minus this, x minus this, x minus this, and then multiplying all together. You will get a headache.
This work?
No, there's no work to be done.
No work.
Easy enough?
Mm-hmm.
Okay.